Hello everyone. I thought I'll do a quick video and show you a little bit about what I've been up to in the last couple of days. I'm a little bit mobile, so what I'll do is I'm going to show you an experiment I've been doing with magnetism and electricity, and it's quite interesting, so just bear with me and I'll explain what is happening. I'm sure those of you who are interested in what I'm busy doing here, or what has been done in the line of Bldc motors and switching them, and so you are all familiar with bridges and half bridges and ESCs, electronic speed controls, that kind of thing. So I'm showing you an experiment which is really about the magnetic field that you're switching in a BLD motor, which is normally a north-south combination. So let me show you. I've got a little thing set up here with an old hard drive motor, and I'm not going to go into too much detail because it's not really what it's about, because you can see many of those on the internet. But this specific one is about having all the magnets in the same direction, and I'll show you the significant difference between the two. So in a BLD motor, you have a combination of north-south magnets running in one after the other, and I will show you something different. Might be very interesting for you. So here you can see a little hard drive motor which I've got set up so that it's just running the BLD motor. You know, it's one of those with the three connections at the back. It's got a ribbon cable onto the three phases, and then obviously the positive. So this experiment, which is adjustable here with a potentiometer. So now this is not really what I'm showing you, so I'm going to disconnect this, and I'm going to rewire an old setup that I made some years ago. It's just when I had a CNC machine, I was able to machine a bunch of components. So I've got a couple of these rotors and a couple of stators that I've made in different configurations to be able to do some tests, and a little setup here that I've built through when I had the CNC machine. So I'll switch this off. So I'm just going to rewire my little half bridge here, which has obviously got the three MOSFETs there. And it's only a half bridge, but I'll show you what it does. On here I've got basically 12 coils, and I've got 8 magnets, and all the magnets here are as in a BLD motor or BLDC motor is north-south all around, and there's 8 of them, so they match up. So the interesting thing here, these magnets get in everywhere. So I have a little magnet that I got from the guys I ordered the magnets from, which gives me basically just a north-south orientation device, which I use to basically see the orientation of the magnets. So these magnets are neodymium magnets. They just push into here that CNC machine rotor, so that it can so that they can just fit comfortably and snugly in there. So what we have here is the north and south, north, south, north, south. So they're alternating, which is very interesting to note. Now this thing on my little bridge doesn't spin by itself, so I just have to help it a little bit. but you'll see now what I mean. So we just get the orientation correctly so that we have the polarity correct. Then you'll see what I'm saying. So my power supply is only a 30 volt 3 amp supply. So I could probably spin this a lot faster if I had a bigger supply. But that's not very important right now. My idea is to keep this thing as economical on electricity as possible. So we would probably eventually run the generator on probably 600, 700, 800 watt, which is of higher current, which I don't have here right now, but the simulation is good enough. So I will set this up, and you will hear the buzz from the coils. So there we go. You can hear that start up by itself. And there we go, it's running. So this would represent now the heavyweight magnets that I have on the heavyweights that are running in the generator. So I'm doing these experiments to see which is the best way to run it and which is the optimum way to get the maximum power out of this configuration. So we've got to test the revs now, which is really why I'm doing this, is to show you what difference it makes if the magnets are oriented in the same direction as opposed to the direction being alternated. So here I'm getting a maximum speed . 1162-63 RPM, which is relatively slow compared to what it's going to do just now, and you'll see. But this is the maximum I can get out of it. So there I've slowed it down now. It takes a while to slow down, so I'm not going to wait for it. I'm just going to show you. So what I'm going to do now is I'm going to take the magnets and I'm going to alternate them so that they're all the same. In other words, it's going to be north-south, north-north every single magnet. I'll show you now. So every second one has changed. So here we have north, 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 north. So all the magnets are now in the same direction, and we will try and run this thing up again. So we just give it that initial spin. So you hear the difference now. I mean, you can already hear that it's going almost double the speed that it would just now on 3 amp. And now I'm running at 2000 RPM. That's 2000 almost 2,200 RPM. 2,300 RPM. Now I'm turning the speed up a bit. Here we go, 2,400 RPM. There you can see. Can you see 2,400 RPM? That's the speed I'm running at now, as opposed to 1,200 RPM when all the magnets were in the same direction. So really what I'm trying to say is that it's 2,000, almost 2,500 RPM still accelerating. And that's on maximum speed here. Yeah, 2,500 RPM. Okay, 2,400. So, I suppose what I'm trying to say is that everybody who's running a BLD motor with changing polarities, it's not as efficient as having the polarity all in the same direction. And the advantage is having all in the same direction means that you're not really limited about the amount of magnets that you can include here. So I thank you for taking the time to listen to this. I'm hoping that you have gathered a little bit of information from this. And then next I will try and run the thing, but there's with my generator there's a couple of things that I'm still busy sorting out to get it to run like this. Although with the generator we only need 1,500 RPM, which is where I'm having my little problem, is to be able to adjust the speed always to be at 1,500 RPM. Thank you for listening, and we will chat soon. Bye.